You've seen it. A semi-truck rolling down the highway, 18 wheels spinning beneath tons of cargo. Except not all of them are spinning. Some aren't even touching the road. They're just there, suspended a few inches above the asphalt, turning uselessly in the air while the truck keeps moving. It looks like a mistake, like something broke, but it's not. It's deliberate. And the reason it happens reveals something most drivers never think about: the hidden mathematics of weight, friction, and failure built into every heavy vehicle on the road. Lift axles, that's what they're called. Extra axles on trucks and trailers that can be raised or lowered depending on the load. When they're down, all the tires touch the ground. When they're up, some wheels hover in the air, spinning freely, contributing nothing. It seems wasteful, inefficient. Why carry extra tires that aren't being used? Why add weight and complexity to a vehicle that's already fighting physics just to move? The answer isn't about power or speed. It's about something more fundamental. It's about the invisible threshold between legal and illegal, between safe and catastrophic, between a load that arrives and a bridge that collapses. Why would a truck be designed to carry wheels it doesn't always need? Here's what most people don't realize. Lift axles weren't invented to make trucks faster or more efficient. They were invented to make trucks legal. In the mid-20th century, as highways expanded and freight tonnage increased, governments realized that heavy trucks were destroying roads and bridges faster than they could be repaired. The problem wasn't the total weight of the truck, it was how that weight was distributed. A 40-ton truck with 4 axles puts far more pressure on each contact patch than the same truck with 6 axles. More pressure means more cracking, more rutting, more structural fatigue. So laws were passed, setting limits not just on total weight, but on axle weight, the amount of force any single axle could apply to the pavement. Lift axles were the industry's answer. When a truck is empty or lightly loaded, the extra axles are raised to save fuel and tire wear. When it's fully loaded, they're lowered to spread the weight across more contact points, keeping each axle within legal limits. The floating tires aren't a glitch. They're a regulatory compromise, a mechanical solution to a political problem. So, how does it actually work? A lift axle is essentially a normal axle mounted on a pneumatic or hydraulic system that allows it to be raised or lowered by the driver. When air or hydraulic fluid is pumped into the system, the axle lifts and the tires leave the ground. When the pressure is released, the axle drops and the tires make contact. The system is controlled from the cab, usually with a simple switch. The engineering is straightforward, but the decision of when to use it isn't. If the truck is carrying 20 tons and the legal limit per axle is 10 tons, 2 axles are enough. But if it's carrying 30 tons, you need at least 3 axles to stay legal. The math is simple. The consequences of getting it wrong are not. Overloaded axles don't just wear out roads, they wear out the truck. Tires blow, suspensions crack, brakes overheat, and in the worst cases, the axle itself fails, sending the vehicle into an uncontrolled slide. Lift axles let drivers and fleet managers adjust to the load dynamically without needing different trucks for different jobs. Most people assume that if a tire isn't touching the ground, it's broken or forgot to be lowered. It looks wrong, inefficient, like someone made a mistake, but that assumption misses the entire point. Those floating tires aren't failing to do their job. They're doing exactly what they were designed to do, which is nothing. When a truck is light, extra axles add drag, increase fuel consumption, and cause unnecessary tire wear. Keeping them raised saves money and reduces environmental impact. The myth is that more tires always mean better performance. The reality is that more tires only help when the weight demands it. This is why you'll see the same truck with all tires down on one trip and half of them up on the next. It's not inconsistency, it's optimization. The truck adapts to the load and the road in real time. But here's where the invisible brilliance comes in. Lift axles aren't just about compliance. They're part of a larger system designed to keep trucks moving even when things go wrong. If a tire blows on a standard axle, the truck immediately loses stability. But on a multi-axle setup, especially one with lift capability, a single tire failure is survivable. The remaining tires can compensate. The axle can sometimes be raised to reduce drag from the blown tire. The system is designed with redundancy built in, assuming that something will fail and planning for it. Modern lift axles also include load sensors that measure weight distribution across the vehicle. If one side is heavier than the other, the system can adjust, raising or lowering individual axles to balance the load. Some systems are fully automatic, responding to weight changes without driver input. This isn't just engineering, it's predictive design. It's building a machine that knows it will be pushed beyond its limits and giving it the tools to survive anyway. If you're finding this fascinating, consider subscribing and hitting the like button. There's a lot more hidden engineering to uncover, and your support helps us keep exploring these invisible systems. But there are limits. Lift axles only work if they're used correctly. Some drivers, trying to save fuel or avoid wear, keep axles raised even when the load requires them down. This is called axle shifting, and it's illegal in most jurisdictions because it defeats the entire purpose of weight distribution laws. Overloaded axles don't just damage roads. They increase stopping distance, reduce maneuverability, and make blowouts far more likely. Enforcement is difficult. Weight stations can catch violations, but they can't monitor every truck on every mile of road. The system relies on compliance, on drivers and fleet managers making the right call even when no one is watching. The other risk is mechanical. Lift axle systems involve moving parts, seals, hydraulic lines, and air pressure systems, all of which can fail. A stuck axle that won't lower when needed or won't raise when it should can leave a truck stranded or operating illegally. And unlike a blown tire, which is obvious, a malfunctioning lift axle might not be noticed until it's too late. And here's the paradox. We've built a freight system that moves billions of tons of goods across continents every year, and most of it depends on a compromise we barely notice. Those floating tires aren't a flaw. They're a symptom of a deeper truth. Our infrastructure wasn't designed for the loads we're putting on it. Our roads are crumbling under weight they were never meant to carry. And instead of rebuilding everything, we invented a mechanical workaround, a way to let trucks keep getting heavier without completely destroying the pavement beneath them. It works most of the time, but it's a patch, not a solution. Every truck with a lift axle is a reminder that we're managing a system at its limits, balancing legal weight restrictions, economic pressure, and structural fatigue, hoping the math holds. And it does, until it doesn't. A truck with wheels that don't touch the ground is a machine in negotiation with reality. It's carrying more than it was built for, on roads that weren't designed for it, under regulations that try to slow the inevitable decay. It works because engineers anticipated the problem and built flexibility into the machine itself. But flexibility has limits. At some point, no amount of clever engineering can compensate for a system being asked to do more than it was designed for. And when you see those floating tires on the highway, you're not just seeing a truck, you're seeing a question. How much longer can we keep adding weight to a foundation that's already cracking? If this video changed the way you see the road, subscribe to The Curious Mechanism and hit the like button. Every subscription helps us dive deeper into the systems you pass every day, but never truly see. This is The Curious Mechanism, exploring the invisible systems that keep the world running.